I'm Geetika. I started Nanobits with a simple goal to bring real awareness and adoption of AI to everyone building products today. No hype, no buzzwords, but the practical stuff that actually works. And here's the thing, I shipped multiple AI features as a product manager this year, and two of them broke in ways I could not explain. One hallucinated confidently, another became extremely slow. The third one actually just drifted. These were the same prompts, but completely different behaviors a few weeks later. What frustrated me the most was that there was no playbook, no structured guidance, and these were just vibes, copied prompts, and the developers were quietly dealing with some chaos. But then I discovered something that changed everything for me, at least a framework that made AI development feel like actual engineering for the first time. And today, I want to take you through exactly what I learned. But before we dive in, a disclaimer that I have used some cool AI tools to create these slides. In fact, I overran the free limit of one of the tool halfway through the slides, so I used another tool to create the remainder of them. I'm also sitting on two different screens, so I have a camera right in front of me on one screen, and then I have my slides that I'm sharing on the other screen. On that note, let's dive in. So, how are the traditional versus AI systems different? Here's the core issue. The traditional software has always been deterministic. You give a function the same input, you get the same output every single time. That consistency is what makes systems testable, scalable, and predictable. Our entire toolkit, unit tests, monitoring, failure analysis, all of it assumes that once you define a rule, the system will follow it. But AI completely broke that assumption. Models are probabilistic. Their behavior depends on context, phrasing, retrieval results, temperature, and variables we never even considered in the classical architecture. This variation shatters the mental models we have relied on for decades. Think about what this means in practice. Um, Tests aren't proofs of correctness anymore. The edge cases become infinite, and the failures have no clear boundaries. And here's the kicker, 78% of the companies, by a report globally, are now using AI daily. But most teams are building without any shared vocabulary or structure. That creates absolute chaos. Let me paint a picture for you of what actually happens. You get prompt sprawl, as they call it, where prompts are copied everywhere, modified randomly, and no one knows what exactly is running in production. You get inconsistent outputs where different users get different answers to the same question, and hallucinations appear randomly. We also know that there are escalating costs because every single request hits your most expensive model with no intelligent routing. It just becomes impossible to test because you can't version prompt, you can't isolate errors or monitor the quality. So you are stuck at prototypes because demos break the moment they face the real user inputs. And what about developers? Well, developers waste weeks trying to debug the impossible. Well, the goal isn't here to fight the probabilistic behavior, it's to wrap the LLMs in enough structure that the overall system behaves predictably even when the model doesn't. That's where the design patterns come in. So, what are AI native design patterns? Traditional design patterns assumed structured functions and classes, but AI native patterns are different. They're model centric, operating at the system level. They address how LLMs behave with context, how outputs drift over time, and how to manage uncertainty. Today, we are going to cover the complete framework, starting with behavior patterns. These are the foundations that make models think predictably before you even add external context. The first up is the structured prompting. This is about creating reusable templates with clear slots and consistent framing. When models follow consistent formats like JSON schemas, fixed fields, and predictable layouts, behavior becomes far less chaotic. A wrong way of asking a question would be, what is my store policy for XYZ? That's vague, unstructured, and will give you wildly different results. Then, what's the right way? Divide your prompt into clear sections. Give it a role. Let's say you're a store policy assistant. Tell what the task is. Answer customers' questions about store policy. Define what the context is. Use the ABC policy document. Tell what the format should be for the output. Output as JSON with these fields like category, urgency, next action, and tell what the constraints are. If you're unsure, say you don't know. Most models now support structured output natively, but even without API support, explicit instructions improve consistency dramatically. So don't let models improvise structure, define it upfront, and force it consistently. Next, let's look at how end-shot prompting helps. This is where you provide 2 to 5 input-output examples to steer the response structure. You show, you don't tell. Models learn by imitation, just like kids. These are high-quality examples, especially covering the edge cases, which help anchor both reasoning and formatting. So, for the customer questions about the store policy that we just talked about, you can actually give it in the exact format the inputs and then tell how the output should look like. That is end-shot prompting. This is what it looks like in practice. You have an input, let's say, I can't believe this amazing feature had just been added. Thank you. And the output would be surprised, the intensity is high, and the sentiment is positive. Another input could be it's fine, I guess, where the mood is neutral, the intensity is low, and maybe the sentiment is again neutral. Now, you can ask the model to classify. Well, that was certainly unexpected. So, this kind of example based prompting is especially powerful for complex classifications, more for nuanced tone requirements and edge case handling. The key over here is selecting examples that span your entire decision space. The third pattern that we'll look at is context framing. This is about clarifying ambiguity, defining roles and rules, and narrowing to task relevant knowledge. LLMs respond to framing, not just tasks, by the way. So, vague frames force the model to guess, versus explicit frames create predictability. For this, you need 3 things. First is to reduce the ambiguity. Tell the model the audience, tone, constraints, business rules. Don't let it improvise. For example, summarize this contract for non-technical executives, focus on financial obligations and termination clauses, use plain language, keep it under 200 words. The second is to set identity and boundaries. Define the model's role and what it should avoid. Again, an example could be you're a compliance assistant, never provide investment advice, only reference approved regulatory documents. The third is to use the right context window. Add only what supports the task. Don't overload with irrelevant information. So when your framing is really tight, the reasoning focuses and the outputs stabilize and failure becomes predictable. Fourth and the final behavior pattern is the prompt versioning and experimentation. Here's the truth. Prompts are code. They have behavior, side effects, and break in production. You need to treat changes accordingly. First, use explicit version IDs. Track which version produced what output. This lets you debug regressions, compare performance, and roll back safely. Second, run controlled experiments. Small edits cause big behavioral shifts. You can use A/B test, you can use shadow tests, you can have canary deployments. Never just replace prompts in production. Third is to manage the life cycle. Update the prompts as retrieval, memory, or guardrails evolve. Iterate, revert, and ship improvements with confidence. Remember, versioning creates feedback loops. You see what breaks, you understand why it happened, you fix it systematically, and you improve continuously. It's the difference between shipping AI and staying stuck in prototypes. Okay, so behavior patterns give you stability at the prompt level, but here's the thing, they can't solve everything. They can't stop hallucinating when the model simply doesn't know the answer. They can't keep your system current when information changes daily. And they can't catch unsafe outputs before they reach users. That's where the next set of patterns come in. Retrieval patterns. Retrieval patterns ground models in reality. Instead of relying on what the model learned during training, we pull relevant facts from documents, databases, knowledge bases at inference time. This keeps system current as information changes and drastically reduces hallucinations for domain-specific tasks. So the fifth pattern is RAG, as a lot of you would already know by now, is called as Retrieval Augmented Generation. RAG is the standard way to ground your LLMs in real information. It replaces keyword search with semantic understanding. And here is how it works. We embed documents into vectors and use semantic search to find content that's actually relevant to the user's query. The top matching chunks get passed into the prompt as context, giving the model specific factual grounding right before generation. This is especially effective for large knowledge bases, and it keeps systems flexible because you can update underlying documents without retraining the model. And on that note, I will need to shift to my next set of slides. So, on the topic of RAG, once you introduce retrieval, you need two critical enhancements. Number one is freshness, which keeps the retrieval indexed aligned with reality. Documents change, numbers update, policies shift. If embeddings don't update, the model hallucinates outdated information. The second point that you need to keep in mind is ranking. Ranking solves the opposite problem. Too much information, vector search returns a mix of relevant and noisy chunks. Ranking rescores candidates to ensure the model sees only the highest value context. So, together, freshness and ranking act as quality control for your retrieval pipeline. The second retrieval pattern is memory. This tracks user state, maintains context across turns, and enables personalization. LLMs don't remember anything on their own. Every call is stateless unless we manage context explicitly. The memory pattern stores relevant pieces of past interactions and feeds them back when needed. This could be conversation history, user preferences, prior decisions, or any state that improves coherence. It makes systems feel consistent and aware. In production, memory is selective. We store only what matters, not entire conversations. And this keeps your context windows manageable, at the same time maintaining continuity. And I'm sure most of you have seen across multiple AI applications and AI assistants that memory is now becoming a core feature. Retrieval grounds models in facts, but grounding alone doesn't guarantee safety, compliance, or reliability. Governance patterns are the control layer that keeps AI systems stable in production. They make failures detectable, reversible, and controlled. Guardrails enforce safety, they detect uncertainty, and validate inputs and outputs. They define what the model cannot do. They are not about making models smarter, they are about making systems safe, predictable, and compliant, regardless of what the model generates. First is to enforce boundaries, safety rules, policy constraints, brand guidelines, compliance requirements. Second is to detect uncertainty. If the model is low confidence, contradictory, or unsure, don't force it to guess. Third is to escalate when violations occur. Switch to retrieval. Run a more reliable model. Fall back to a deterministic rule. Or hand it off to a human review. Guardrails protect users, protect systems, and ensure that the next step is always safe. The final governance pattern is tracing and feedback. This is your observability layer. If guardrails define what should not happen, tracing tells you what actually happened. They capture the full story of every request. prompt version, model used, retrieved context, latency, output, retries, escalations. Without this, debugging is just guesswork. The other half is about feedback, user reactions, correction signals, thumbs up, thumbs down, or automated judges that score outputs. These signals show where models struggle and where prompts need tuning. Now, here's where all of it comes together. The real AI systems never rely on just one pattern. They become reliable when patterns work together. So, let me show you what happens within a single query in a real production system. Imagine you are a customer support bot for a department store. I mean, obviously you are not, but there is a customer support bot for a department store. And when a user asks a question, here is exactly what happens behind the scenes. In the offline world, we construct the system prompts with behavior patterns and test against various models. In the online world, when the query arrives, number one, intent classification is happening using structured prompts, determining what the user really wants. Number two is routing, which decides which model or workflow to use. Number three is retrieval, which pulls relevant context and ranks the best pieces. Number four is the generation that actually is producing the final output. Number five is the schema validation, which ensures that the structure is correct. Number six is the guardrails, which check confidence, safety, policy. Number seven that you're doing is tracing, which is logging everything for debugging. And number eight is the feedback collection that is capturing the user's reaction. So even though the user sees one answer, that query touched 8 different patterns behind the scenes. This is what AI native really means. Not one clever prompt, not one powerful model, but a composition of patterns working together, where each handles one responsibility and the overall pipeline is testable, versionable, and monitorable. So here's the bottom line. AI systems fail in ways traditional software does not. They drift, they hallucinate, they vary unpredictably. But with the right patterns, we can wrap probabilistic models in enough structure that the overall system behaves reliably. So, if you are building, start with one pattern. Add structured prompting to one feature. Version one prompt. Implement basic training and then build incrementally. And if you are a leader listening to this, invest in the AI infrastructure now. Prompt management systems, evaluation frameworks, observability tools, all of them need to go hand in hand. They are no longer nice to haves. In fact, they are requirements for shipping at scale. The gap between demos and productions isn't about finding better models anymore. It is about engineering discipline. These patterns are how we will close these gaps. On that note, I love to close my presentation now. If you found this helpful, please subscribe to our Nanobits newsletter as well as this YouTube channel, because every week we are breaking down new developments in the space of AI, what's actually working in AI products, the new AI tools, as well as policies that are shaping this space. And believe me, we share no hype, just practical insights that you can use. The link is in the description. Thank you for watching, and I will see you in the next one.